Here is question number 21. A cup of tea cools from 80 degrees centigrade to 72 degrees centigrade in 5 minutes of time, and then from 72 to 66 degrees centigrade in next 5 minutes of time. Then what will be the temperature of surroundings? So the question belongs to Newton's law of cooling, and we know according to Newton's law of cooling, the rate of change of temperature with time will be directly proportional to T minus T naught, where T is average temperature and T naught is temperature of surroundings. And this is actually Newton's law of cooling. According to Newton's law of cooling, we got this kind of expression. Now let's write this expression for both the cases, from 80 to 72 and from 72 to 60. Case number 1, dt1 upon dt proportional to the average of 80 and 72. We will get 76 minus surrounding temperature T naught, which we have to obtain, and which is dt1. The change is from 80 to 72, that is 8. So 8 by 5, which is dt, time 5 minutes, proportional to 76 minus T naught, taking as equation number 1. Let's do the same for second case also, from 72 to 66. dt2 by dt, the time is again 5, but the change in temperature is 72 to 66 degree, that is 6, proportional to average of 72 and 66 gets you 69, minus surrounding temperature will be the same. Equation number 2. Taking the ratios, ultimately what we are going to get, we will get 8 by 6 equals 76 minus T naught whole divided by 69 minus T naught. Solving it, 4 by 3, and after cross multiply we will get the value of T naught. After solving, we get T naught equals 48 degree centigrade. So if you search the option, we will find that we have to go with option number 3, which is absolutely correct. Now let us proceed to the next question, that is question number 22. Here is question number 22. A wire of length L is stretched by a force capital F to cause an extension X. Another wire of same material and same volume but 50% larger in length than the first wire. What will be the force required for the same extension? Now we know according to the Hooke's law, Young's modulus is given by force multiplied by actual length divided by area multiplied by extension. Something like this. Here in this case, the wire are of same materials, so Young's modulus for them will be same. Extension for them is also same as per given in the question. Their volume are same, V1 equals V2. We know for any wire the volume is given by area into length. So A1 L1 equals A2 L2. Suppose A1 is A, L1 is L as per question. A2 we need to find out. L2, information is given about L2. L2 is increased by 50% than the previous one. So L plus L by 2, that is 3L by 2. So ultimately we got the final area A2 as 2A by 3. Now since both Young's modulus are same, so Y1 equals Y2. Let's write the expression for Y1. Force F1, length L1, area A1, extension is same, delta L. Force F2, length L2, area A2, and extension is same, delta L. Cancel delta L and delta L. Put the values. F1 has F value, L1 has L value, area has A value, equals F2 we have to find out, L2 3L by 2 multiplied by A2 2A by 3 goes at the numerator. A will be cancelled out with A, L will be cancelled out with L. So ultimately we will get the value of F as 9F2 divided by 4. As a result, we can get the value of F2, that is 4F by 9. So this is our final answer which we have to find out, and if we look for the option, we can say that option number 4 is absolutely correct. So we will go with option number 4. Now let us proceed to the next question, that is question number 23. So here is question number 23. A satellite revolves in a circular orbit of height 1.6 into 10 power 6 meter above the surface of Earth. If the Earth radius is 6.4 into 10 power 6 meter, then orbital speed of satellite will be what? Taking g as 9.8 meter per second squared. We know that the orbital speed of satellite revolving around the Earth will be given by capital G times mass of Earth divided by distance from the center of Earth under root. Now, suppose this is the center of Earth and here is the satellite revolving in circular orbits. Distance from the surface is h, and if radius is r, then the distance from the center will be r plus h. So plugging the values, we get under root g m upon r plus h. Now we know very well that capital G, capital M replaced by small g, radius of Earth square. So that's why r comes out of the root and inside you get g. Plugging the values, r has the value 6.4 into 10 power 6. H has 1.6 into 10 power 6. So we can get 10 to the power 6 as common. It comes out and we get r, that is 6.4 into 10 to the power 6 divided by 10 to the power 3 under root, value of g is 9.8 and 6.4 plus 1.6, that is 8. 4.9 divided by 4. After solving, we can get the orbital speed approximately equals 7 km per second. So this is our final answer, and if you search the option, we can say that option number 2 is absolutely correct. So we will go with option number 2. Now let us proceed to the next question, that is question number 24. Here is question number 24. The extra pressure required to decrease the volume of liquid of bulk modulus 2.5 gigapascal by 0.01% is what? Here change in volume is written, that is percentage change, delta V by V into 100 is given 0.01%. So we can write delta V by V as 0.01 divided by 100. We know very well the bulk modulus is given by minus of pressure into V upon delta V. Here negative sign shows the compression. So as a result, we can write the pressure is B times delta V by V. Let's plug in the values. B has value 2.5 gigapascal. So 2.5 into 10 to the power 9 pascal multiplied by delta V by V. Already we have taken 0.01 whole divided by 100. And after solving, we'll get the magnitude of pressure P as 250 into 10 to the power 3 pascal. That is 250 kilopascal. So this is our final answer. And if we go for the options, we can say that option number 3 is absolutely correct. Now let us proceed to the next question, that is question number 25. Here is question number 25. A vertical U-shaped tube of uniform cross-section contains mercury in both limbs. So this is mercury, this is mercury. Another liquid of density 3.4 gram per centimeter cube is poured in one limb for column 4 centimeter as shown in figure. So this is another liquid of density 3.4 gram per centimeter cube. The difference H between the upper level of liquid in both limbs will be what, given that the density of mercury is 13.6. I just want you to consider 2 points, point A and point B. both point A and point B are at the same horizontal level in the same liquid. So that's why their pressure will be same. Since we know very well A and B are at the same horizontal level, of the same liquid, therefore the pressure at A must be equal to the pressure at B. We will not take the atmospheric pressure because atmospheric pressure will be considered from both sides, here as well and here as well. So pressure at A. See, the column of liquid above A is 4 centimeter, already given. The column of liquid above B is, we can write 4 minus H. Now putting the values, pressure at A, that is density ρ1 into gravity into H, or you can write H1, equals pressure at B, density ρ2, here it is mercury, into gravity G, into height H2. Let's say G will be cancelled out. Density 1, that is liquid at the left side, which is 3.4 in centimeter cube given, multiplied by H1 is 4, equals density of mercury, that is 13.6 ρ2 into H2 given 4 minus H. After solving, we can get 4 minus H as 3.4 multiplied by 4 whole divided by 13.6, and by cancelling with 17 you will get 0.2 upon 0.8, and which is equal to 1. So 4 minus H gets you the value 1. As a result, H equals 4 minus 1, that is 3 centimeter. The height H, we have got 3 centimeter. Therefore, if we see the option, we'll find that option number 3 is absolutely correct, and we will go with option number 3.